Bloom focuses both on students and professors who are teaching or learning about artificial intelligence. We want to provide them a tool that simplifies the creation and understanding of machine learning models. In Bloom, users can create projects and link them to different datasets. Then they can create inside the project different block sequences to build their own model. Each of these blocks represent the typical functions we would use in traditional programming. In the future, we also aim to add classes so that professors can create personalized tasks to give to their students. Then we also want to add a simple interface for dataset cleaning.
Additionally, we plan to add new blocks to create a more variety of different models. And lastly, we plan to have a training section so this can be a more user-friendly environment.
Bloom is an educational web application that offers a visual introduction to a topic of machine learning. It provides a graphical alternative for a user-friendly and intuitive way of learning this topic.
Concepts such as machine learning or programming can be very challenging to learn. Scratch took advantage of this situation and became the first step for many in the world of programming. The same thing happens when trying to code machine learning models. It can be very hard, so we created Bloom. We took Scratch concept to the field of machine learning.
Our goal for this tool is for it to be implemented in the teaching of machine learning in schools like ours, especially in the modern world where machine learning is increasingly being implemented in most day-to-day tasks.
In many parts of the world, especially in rural or less developed areas, a significant problem is the lack of access to specialized dermatological care. Also, dermatological consultations can be expensive, and not everyone can afford multiple visits for diagnosis and treatment, creating significant economic barriers. That's why my teammates and I developed the Dermalize project, which offers an innovative and effective solution to these problems, by providing quick and accurate analysis of dermatological issues through a mobile app. To start the project, since it involved developing artificial intelligence, we researched the topic, methods for building and training it. First, Jeremy Batcher, our professor and project mentor, recommended that we begin by researching image recognition with AI using a basic case, an AI that identifies whether an animal in an image is a cat or a dog. We learned how to build this AI from various professionals who shared their code and how it worked on YouTube. That's when we discovered TensorFlow and Python, a library and language that made using AI easier. We searched for datasets, in this case, images, of dogs and cats and selected images to train and test the AI. We created the model for the AI, which had 3 neural layers. These layers initially process a small part of the image and, layer by layer, analyze progressively larger parts. Through training, the AI learns to recognize patterns in the image and determine which patterns are more common in cats or dogs, providing a conclusion based on that. After training, you could give it an image and it will return a possible result. Once we completed this model, we swapped the training data for images of benign and cancerous melanoma skin tumors. We expanded the model by adding more neurons and layers, which improved its diagnostic capability. We trained the AI, achieving a 75% accuracy rate in diagnosis whether a skin tumor was cancerous or not. Next, using Fast API, a Python library for creating APIs, we set it up so that a photo could be sent to the AI and receive a diagnosis in return. Finally, we uploaded this API to the cloud so it could be accessed from any device. With Dermalize, users can now get an instant dermatological analysis by taking a photo of the affected skin, eliminating the need for long waits and travel. By identifying potential skin conditions and providing treatment recommendations or suggestions to consult a specialist, Dermally speeds up the healthcare process, helping to prevent complications from delayed diagnosis.